All right. Here we go. Getting logged in. Gonna light the candle. You know, as I do. Happy Monday to everyone. Sorry the stream was a little later today. I had a conflict this morning at 12, but we are back on track now. I'm gonna pause. Not sure why that is not doing what I wanted to, so we're gonna change that. Yes. So today we're working on more of command line. Super excited. It's gonna be I feel like we're starting to get into the meat of the material, like actually something that I haven't encountered before. We're not just looking at like, what is a computer? It's actually like interesting things. All right, there we go. And I'll just put my, okay. Apologies for my disorganization. Cool. Awesome. Gonna get, yes, logged in, web browser, and then pull up our terminal. Oop, helps if I, there we go. So I took up a whole bunch of notes last time. Here's my handy dandy legal pad. Will be a staple throughout the series. Another fun thing, I started this morning working through an algorithms textbook. So once I have PowerPoint materials ready for that, I'm going to start working through that with y'all, or just by myself. But I'll be sharing it. I'll be sharing it with you. Okay. This is the site that we were working through, and then we had gotten through setup, introducing shell, and then navigating files. So we're going to click on working with files and directories, and then we'll also do the next one, the pipes and filters today. Super exciting! All right, so working with files and directories. The questions for this one are, how can I create, delete files and directories, and then how can I edit files? So I'm going to kind of move this around a little bit better. Pull this over here so we can interact with it a bit better. Make it a little larger. Ooh, there we go. We're doing the things. Okay. So, questions, how can I create? We already went over that. Objectives for this lesson are create a directory hierarchy that matches a given diagram. Create files in that hierarchy using an editor or by copying and renaming existing files. I'm going to close this book. I forgot that it was open. I don't want the spine to get book. Oops. Okay. Create files in that hierarchy using an editor or by copying and renaming existing files. Delete, copy, and remove and move specified files and or directories. Cool. So we're going to start with creating directories. Just going to scroll down a little bit. Okay, we now know how to explore files and directories, but how do we create them in the first place? In this episode, we will learn about, we will learn about moving, creating files and directories using the exercise data / writing directory as an example. So step 1, see where we are and what we already have. So we should be in the shell lesson data directory on the desktop, and we can check using this. So I'm going to go over here, and this is going to show me that I'm just in my home directory. So I'm going to go ahead and ls, and that shows me all of the different things that are on my within my directory. So now I'm going to actually go to cd squiggly This is really good for me. This is a good little recap. So that's going to be, and then I want to go to desktop, and then shell lesson data. Alright, now it shows that we are actually in this shell lesson data. We got there. I'm actually quite proud of that, because we remembered from last episode. Alright, so now we are actually going to change directory. Even one more, we're going to go into exercise data writing. Alright, and now we're going to lsf, and that will show that we have both haiku text and Little Women text documents. Cool. And scroll down. Next step is to create a directory. So I'm going to write this down because this is going to be new. Make directory is the command. So mkdir just means make directory. I love it when things are like straightforward like that. It makes it so much more simple and easy. So we're going to mkdir, and then the name of our directory is going to be thesis. Ooh, my M key is sticky, so mkdir, thesis. Now this one should work. Great. Now we've made another directory within writings called thesis, and it has nothing in it, but we will type lsf, and that will list everything, and thesis is now listed as a directory. Stomach's growling. As you might guess from its name, mkdir means make directory. Since thesis is a relative path, it does not have a leading slash like slash what slash ever slash thesis. The new directory is created in the current working directory. So we'll just show our directory like we have done. And then we'll go ahead and do this again. So ls f thesis, and there's going to be nothing in it, so it's not going to show anything. That's great. So mk make directory is not limited to a single directory at one time. One at a time. The -p option allows make directory to create a directory within nested subdirectories in a single operation. So you would type in make directory -p and then ..project data .project results. The -r option to the ls command will list nested directories within a directory. So I'm going to write that one down. -r list all nested subdirectories. Within a directory. Oops. Within a directory. Great. So let's use ls-fr to recursively list the new directory hierarchy we just created in the project directory. So I didn't create one in the project directory. I'm going to go ahead and do that right now. So mkdir and then -p dot project data dot project results. Cool. Now we are going to ls-fr dot project. And that will give us what we had just made. That is data and results. So it's two ways of doing the same thing. Using the shell to create a directory is no different than using it File Explorer. If you open the current directory using your operating system's graphical File Explorer, the thesis directory will appear there too. While the shell and File Explorer are two different ways of interacting with the files and directories are themselves the same. So good nomenclature for files and directories. Complicated names can make your life painful when working on the command line. Here we provide a few useful tips for naming files and directories. So don't use spaces. Spaces can make a name more meaningful, but since spaces are used to separate arguments on the command line, it's better to avoid them in files or directories. You can use dash or underscore, such as north-specific-geir, rather than north blank specific blank geir. To test this, try out typing. Sorry, there was a weird whirring sound outside of my house. Is it aliens? North Pacific geir, and this will probably give us multiple directories, is what I am guessing. So we are going to ls f, and it's going to be North Pacific geir. Not so good. Not so good. So we also don't begin names with dash. Commands treat dash as an option, which we can see we've been using options like -f, -r, -p. So we won't use dashes to begin a name. And then stick with letters, numbers, period or full stop, dash, and underscore. Many other characters have special meaning on the command line. We will learn about these in some of the lessons. There are special characters that can cause your command not to work as expected or even result in data loss. If you need to refer to file names or directories that have spaces or other special characters, you should put quotes around the names so that it reads it all as one string. Alright, creating a text file. Let's change our working directory using cd. So we're going to change directory, thesis. Now we are in, I did it wrong. Helps if I spell it right. No. Okay. Now we will use a text editor called Nano to create a file called draft.txt. So we are going to type nano draft.txt. Cool. I'm going to type that down. So this is a text editor. Text editor Nano. Just writing down that syntax. Okay. So when we say Nano is a text editor, we do not mean text, because it can only work with plain character data, not tables, images, or other human-friendly media. We use it in examples because it is one of the least complex text editors. However, because of this trait, it may not be powerful enough or flexible enough for the work you need to do after this workshop. On Unix systems such as Linux and Mac OS, many programmers use Emacs or vim, both of which require more time to learn, or a graphical editor such as Gedit. On Windows, you can use Notepad++. Windows also has another built-in editor called Notepad that can be run from this command line the same way as Nano for the purpose of this lesson. No matter what editor you use, you will need to know where it searches for and saves files. If you start it from the shell, it will probably use your current working directory as its default location. If you use your computer's start menu, it may want to save files in your desktop or documents directory instead. You can change this by navigating to another directory for the first time you save as. Cool. Now let's type in a few lines of text. Once we're happy with our text, we can press Control O. So press the Control key while holding it down. Also press O. To write our data to disk, we'll be asked what file we want to save this to. Press Return to accept the suggested default of draft.txt. So, should we copy their text or make our own? I'm just going to say, should we copy or make our own? Let's make our own. This is our text. Okay, so now we've made this file. It's very complex. We're going to click Control O. So it was written to draft.txt. Now that our file is saved, we can use Control X to return back to our shell. So I'm going to click Control X. Maybe we can. Uh-oh. It's really thinking. I can't do anything. Oh, yes. Cool. I just needed to confirm. Oops. Alright. Now we will Control X. Great. The control key. So the control key is called CTRL, just abbreviated. There are various ways in which the control key may be described. For example, you may see an instruction to press the control key while holding it down, press the X key, described as any of the following. So Control X, Control plus X, and then abbreviated Control X. Yeah. The little caret symbol can also be used for control. In this context, it does mean the control key and not the caret key, which can be found in Shift 6. We would use the control key for that. And then C-6 will also mean Control X. In Nano, along the bottom of the screen, you'll see the caret key used. That means you can use Control G to get help, or Control O to save your file. Nano does not leave any output on the screen after it exits, but ls now shows that we have a file called draft, so ls. Now we have a text file. Super exciting. So we have seen how to create text files using the Nano editor. Now we'll try the following command. Touch myfile.txt. So let's do that. Touch myfile.txt. So it looks like we created another text file. This one will likely be in a different, like we didn't use Nano to create this file, so let's see what this says. So Touch generates a new file called myfile in your directory. You can observe this newly generated file by typing ls at the command prompt, and then myfile can also be viewed in your my GUI file explorer. When you inspect with ls-l, note that the size is 0 bits, and otherwise it contains no data. If you open myfile with a text editor, it is blank. So some files do not generate file outputs themselves. Some programs don't generate file outputs themselves, but require that empty files have already been generated. When the program is run, it searches for an existing file to populate with its output. The touch command allows you to efficiently generate a blank text file by using such programs. So, for use by such programs. So I'm going to just write touch name.txt creates a file. Creates empty file. Good stuff. So to avoid confusion later on, we suggest removing the file you just created before proceeding with the rest of the episode. Otherwise, future outputs may vary from those given in the lesson. To do this, we'll use the following command. Good stuff. So rm my_file.txt. So we have now deleted that file, or we have removed that file. Huzzah. So what's in a name? You may have noticed that all of Nell's files are named something.something, and in this part of the lesson, we'll always use the extension .txt. This is just a convention. We can call a file my thesis or anything else we want. However, most people use two-part names most of the time to help them and their programs tell different kinds of files apart. The second part of such a name is called the file extension and indicates what type of data the file holds. TXT is a simple plain text file. PDF indicates a PDF document. CFG is a configuration file full of parameters for some other programs, and then PNG is an image, so on and so forth. This is just a convention, albeit a very important one. Files contain bytes, and it's up to us and our programs to interpret those bytes according to the rules of our plain text files, PDF documents, configuration files, images, and so on. Naming a PNG of a whale.mp3 doesn't somehow magically turn it into a recording of a whale song, though it might cause the operating system to try to play it with a music player when someone double clicks it. Oops. I wonder what an image of a whale would sound like. You would need some other type of program to do that. Okay, returning to the shell lesson data. Alright, so we're going to change directory is what it's saying. So we are going to cd tilde desktop shell lesson data exercise data, and then back to writing. So we should now be in our writing directory within the shell lesson data. In our thesis directory, we have a file called draft, which isn't particularly informative name. So let's change the name using mv, which is short for move. So I'm going to write that down. mv is equal to move. Great. So when I upload this to YouTube, I'll likely list all of these command line prompts in the description of the video so that you have a quick reference guide for any of the commands that we use today. And that'll be useful for me too. That way I have a place where it's stored, ready to go, in case I need to refer to it later. So we are going to click MV, thesis, draft.txt. And we are going to move that. We are renaming it to thesis quotes.txt. Okay. So the first argument tells move that we are moving, while the second is where to go. So in this case, we're moving from thesis drafts.txt to thesis quotes.txt, which has the same effect as renaming the file. Sure enough, ls shows us that thesis now contains one file called quotes. So we're going to show ls thesis, and now we have quotes.txt. One must be careful when specifying the target file name, since MV will silently overwrite any existing file with the same name, which could lead to data loss. An additional option, MV-I, or move interactive, can be used to make MV ask you for confirmation before overwriting. So I'm just going to write down that .I stands for interactive, and then it'll ask for confirmation. So -I, interactive, asks for confirmation. Cool. So move also works on directories. Let's go ahead and move quotes into the current working directory. When we use move once again, but this time we'll use just the name of a directory as the second argument to tell MV that we want to keep the file name but put the file somewhere else. This is why the command is called move. In this case, the directory name we use is this special directory name dot that we mentioned earlier. So that's going to move us to the current directory. So mv thesis quotes.txt, and then our directory is going to be .I. I have so many typos. This is really good for me. I need to work on that. Thesis /quotes.txt. It works that time. Helps when you actually type it the correct way. Okay. So the effect is to move the file from the directory it was in into the current working directory. So we type in ls thesis, and then it shows nothing because there's nothing in thesis. Alternatively, we can confirm that the file is no longer present in thesis by explicitly trying to list it, and it will return an error. So ls thesis quotes.txt, and then it will return this error: cannot access thesis quotes, no file or directory. So that's a good thing to know. ls with a file name or directory as an argument lists the requested file or directory. If the file given as the argument does not exist, the shell returns an error as we saw above. We can use this to see that quotes.txt is now present in our current directory. So let's go ahead and type ls quotes.txt, and that'll show us that it is indeed in our current directory writing. So moving files to a new folder. After running the following commands, Jamie realizes that she put sucrose.dat and maltose.dat into the wrong folder. The files should have been placed into the raw folder. So ls-f, analyzed, raw, and then analyzed shows fructose, glucose, maltose, and sucrose, and then cd analyzed. So fill in the blanks to move these files to the raw folder, the one she forgot to put them in. Okay. So we're going to do it might need to be ... and then /raw/. Yeah, because that would move us up, that would move us back one directory and then into the directory that we want. So it'll refer to the parent directory if we are in analyzed, and then raw is where we wanted to put those files. So yay, we did it. Alright. Copying files and directories. The cp command works very much like move, except it copies a file instead of moving it. We can check that it did the right thing using ls with 2 paths as arguments. Like most Unix commands, ls can give multiple paths at once. So I'm going to write down cp. cp means copy. Alright, and then in our shell we're going to write cp quotes.txt thesis /quotations/txt. And then we are also going to put ls quotes.txt thesis quotations.txt. And now we can see I did something wrong. Oh, I'm going to try all of that again. So cp quotes.txt thesis /quotations.txt. I did a slash last time instead of a dot. Helps if I do that right. And now we can ls quotes.txt and thesis /quotations.txt, and it should show us both. We did it right that time. Great. We can also copy a directory and all its contents by using the recursive option -r. So I'm going to write that down, -r. So $R listed all directories within subdirectories within a directory. Lowercase is recursive. To go back up a directory. Go back up a directory. So that will look like, I'm going to make this a little bigger actually. Great. And this is getting really messy, so I'm going to clear that. Just for my brain. Helps it to be a little bit more concise for me. Alright. So we're going to copy dash lowercase r thesis, and then thesis underscore backup. Cool. Now we're going to list that thesis underscore backup. I did it wrong. My typo. There we go. Alright, so here it lists that we have thesis holds quotation.txt, and then thesis backup also holds quotations .txt. Great. So that just allowed us to go back up a directory and then copy it to, I believe we created a directory as well as going back. So we went up, created a new directory within the parent, and then copied the text file to that new directory within the parent, that subdirectory within the parent. Okay. So renaming files. Suppose that you created a plain text file in your current directory to contain a list of statistical tests you will need to analyze your data, and you named it statistics.txt. It's a good name. After creating and saving this file, you realized you misspelled your file name. You want to correct the mistakes. Which of the following commands could you use to do so? So, cp, so copy statistics.txt to statistics.txt. That would work. Move statistics.txt, statistics.txt, spelled correctly. That would also work. You just have to make sure that you don't have a pre-existing file name called statistics.txt because it will overwrite it. And I believe that the bottom ones will not necessarily work because there's no, because that would indicate the current directory. It does not give a file name to move it into. Yeah. Oh. So the first one, I said yes to the first option, and it is incorrect because it would create a file with the correct name, but the incorrect file would still exist and would need to be deleted. So it didn't like that because it would still need to be deleted. It says in that case to only use the move option. So moving and copying. What is the output of closing ls command in the sequence shown below? So pwd, our current working directory, shows that we are in users, Jamie, data, and then ls shows that within data we have a text file or a file named proteins.dat. So we are going to make a directory within data called recombined, and then we are going to move proteins.dat into recombined, and then we are going to copy recombined recombined proteins.dat into our parent directory data. We are going to copy that as proteins_saved.dat. So our list should now show both the subdirectory recombined and our file called proteins.dat. So I'm going to say number 3. So we'll start in user directory, create a new folder, move the file into the recombined directory, copy that file back up into the parent directory. Oh no. So it would be even above the, so because we were, okay, it makes sense. So recall that dot dot means go up a level. So the copied file is now in users Jamie, not in users Jamie data. So we hadn't actually gone into the directory recombined, which is what I was working under. We only had stayed in the data directory and created that file and put that file into the new directory. And then we were copying it into the one above where we were at. So it would actually be in users Jamie. So within our current directory, it would only be recombined, which is option 2, which is the correct answer. Oops. Good to know, though. Alright, removing files and directories. Returning to the shell lesson data, exercise data, writing directory. Let's tidy up. So I'm just going to do this, show me where I'm at. We are in the correct directory. And we are going to remove, so rm, our text file. So rm quotes.txt. So we have removed that file. And then ls quotes.txt is going to return us an error because no such file exists. So deleting is forever. The Unix shell does not have a trash bin that we can recover files from, though most graphical interfaces to Unix do. Instead, when we delete the files, they are unlinked from the file system so that their storage space on the disk can be recycled. Tools for finding and recovering deleted files do exist, but there's no guarantee that they'll work for any particular situation, since the computer may recycle the file's disk space right away. So if you're deleting something, make sure it's something that you want to delete. Use rm safely. What happens when we execute rm-i, so that means interactive, so it's asking for confirmation. Thesis backup quotations.txt. Why would we want this protection when using rm? So this is going to ask us to confirm that we want to remove the file, and we might want this protection just to double check that we are in fact deleting the correct file name, since it's gone once it's gone. The I option will prompt before every removal. Use Y to confirm and No to keep the file. The Unix shell does not have a trash bin, so all the files will disappear forever. Use the I option. We have the chance to check that we are deleting only the files that we want to remove. So if we want to remove the thesis directory using rm thesis, we will get an error message. So let's try that. Rm thesis. And it cannot be removed because it's a directory, so rm only works on files. I'm actually going to write that down right quick. So rm is remove files. Hi Captain Coda, welcome to chat. So rm thesis is directory, not a file. Rm can remove a directory and all of its contents if we use the recursive option -r, and it will do so without any confirmation prompt. So, given that there is no way to retrieve files deleted, I'm doing well. How are you doing? Given that there's no way to retrieve files using the deleted using the shell, it should be used with great caution. You might consider adding the interactive option. Operations with multiple files and directories. Oftentimes, one needs to copy or move several files at once. This can be done by providing a list of individual file names, or specifying a naming pattern with wildcards. So, copying multiple file names. For this exercise, you can test the commands in the shell lessons data slash exercise data directory. So I'm going to cd desktop shell lesson. There was an easier way to do this. Okay, and we should now be in this. Great. So we are going to make a directory, called backup, and we are going to copy creatures minotaur dot and creatures unicorn dot into backup. Great. So in the example below, what does CP do when given 3 or more file names? So we are going to change directories into creatures, and then we are going to list. So we have basilisk, minotaur, and unicorn. We are going to copy those, minotaur, unicorn, and basilisk. Well, we didn't have a directory as our argument, so it's just saying that we don't have a place to put it, basically. So I've given more than one file name followed by a directory name. The destination directory must be the last argument. CP copies the files to the named directory. If given 3 file names, CP throws an error such as the one below because it expected a directory name as the last argument. I believe if we had given a directory name instead of a file name as the last argument, it would have just copied all 3 into that directory. It wouldn't have been an issue. Alright, using wildcards for accessing multiple files at once. Asterisk is a wildcard, which matches 0 or... I'm going to clear this right quick. Sorry for being a little sporadic. Makes it nice and clean. Asterisk is a wildcard, which matches 0 or more characters. Let's consider the shell lesson data, exercise data, proteins directory, asterisk.pdb. Matches ethane.pdb, propane.pdb, and every file that ends with pdb. On the other hand, p** pdb only matches pentane, pdb, and propane because they start with p. So question mark is also a wildcard, but it matches only exactly one character. So question mark ethane would match methane, whereas asterisk ethane matches both ethane and methane. Okay. Wildcards can be used in combination with each other, so 3 question marks ane.pdb matches 3 characters followed by ane, giving us cubane, ethane, and octane. When the shell sees a wildcard, it expands the wildcard to create a list of matching file names before running the command that was asked for. As an exception, if a wildcard expression does not match any file, bash will pass the expression as an argument to the command as it is. For example, ls *.pdb in the proteins directory, which contains only files ending with pdb, results in an error message that there is no file called pdb. However, generally commands like wc and ls see the list of file names matching these expressions but not the wildcards themselves. It is the shell, not the other programs, that deals with expanding wildcards. So when run in the proteins directory, which ls command will produce this output? So we want it to end in PDB. I kind of like So asterisk, we want both E and methane. So I kind of think 2. I'm thinking 2 is the answer because we want any combination of letters that come before T, so to have E and ME, and then we want only A afterwards, so that would be specifically, or we only want HA. Oh, but it is only 1. So I think 3 actually. 3 would be, so my final answer. Okay, so the solution is 3. The first option shows all file names that contain 0 or more characters, followed by the letter T, then 0 or more characters followed by A. This gives us too many options because we only want methane and ethane. So 2 shows all files that start with 0 or more characters, followed by the letter T, then a single character, then Ne. So that would give us octane and pentane, but not ethane or methane. 3 gives option 2, but includes a second character, which has that H in it, which is what we wanted. And then 4 only shows files starting with ethane. So a little bit more on wildcards. Sam has a directory containing calibration data, datasets, and description of datasets, as shown below. Before heading off to another field trip, she wants to back up her data and send some datasets to her colleague Bob. Sam uses the following commands to get the job done. So copy wildcard dataset wildcard, backup datasets, and then underscores calibration underscores backup calibration, copy 2015 blank blank, send to Bob all November files, and then copy blank, send to Bob all datasets created on 23rd. So we need to help by filling in the blanks. So she wants all of the files created on the 23rd, so we would put an asterisk in here, and then a 23 in here. So I'm actually going to write this down, just so that we have a visual representation. And I don't want to do it in the command line because it's going to give us a bunch of errors. So we're going to do cp asterisk dataset backup datasets, and then copy. Here's our first blank. So So we're copying asterisk calibration because that will be any number of characters before calibration So it looks like she's only sending the calibration data? I'm a little bit confused, but we're gonna just try this. So it looks like it would just be these two that she would be sending. Anyway, so asterisk calibration, and then we could even include .txt because that's going to be the end of the file names, and then backup calibration. So I'm going to go ahead and write that down. So that's going to be asterisk calibration .txt, and then we are sending that into backup / calibration. Cool. So that would catch these 3 calibration files. And then for our next line, we are going to copy, and that is going to be 2015 dash asterisk dash 23 asterisk, I think. Send to Bob all Oh, so that's going to be all November files, so I did that wrong. Instead of 2015, we're going to put 11 instead of our asterisk, and then asterisk after that. This looks really messy on this page. Sorry about it. And then our last one is going to be copy copy, and then asterisk dash 23rd dash asterisk, and then we're going to send to Bob, and that is going to go into a new directory called all datasets created on a 23rd. So I'm going to show this to you, but it looks really bad because it's very messy, but it's these lines here. And I'm just going to check it. So the resulting directory should look like this. It should have the 3 calibrations, so backup, calibration, and then we have the 3 texts, which is what we wanted. And that was done by using asterisk calibration.txt. And then we have another directory called datasets, and that would have the rest of the files within it. And then there's a directory called send to Bob that holds all datasets created on 23rd, and then all November files. So I'm going to open this solution and see. So our first one is apostrophe calibration.txt, so that one we did right. And then copy 2015-11 asterisk, that one's right also. And then, oh, I didn't do the last one right because we wanted only data sets, and I did all files. So I would want to edit my command line prompt to be *-23-dataset apostrophe, so that it only pulls data sets made on the 23rd instead of all files. So I messed that one up. Otherwise, not too shabby. Doing pretty good. Okay, so now organizing directories and files. Jamie is working on a project and she sees that her files are not very well organized. Same. So we're going to do ls-f, which gives us our very messy directories and file names. Fructose and sucrose contain output from her data analysis. What commands covered in the lessons does she need to run so that the commands below will produce the output shown? So ls-f will show analyzed and raw, and then ls analyze will show fructose and data. So we need to move so most efficiently would be to move, so mv, and then the file names we're going to put fructose.dat and sucrose.dat, and then put in our argument as analyzed, and that will move these files from our parent, our current working directory into the analyzed directory. So I'm going to see if that. Oh, and it's much easier if we just use an apostrophe. See, they gave me a shortcut and I didn't even use it. No, but that makes a lot of sense. Using the apostrophe makes it so you don't have to type as many things, and you have you're less likely to make a typo like I do so much. I'm gonna take some water. Sorry for that sound, gross. Okay. Jamie needs to move her files to the analyzed directory, so the shell will expand apostrophe.dat to any and all .dat files within the current directories, and the move command then moves it to that analyzed directory. So reproducing a folder structure. You're starting a new experiment and would like to duplicate the directory structure from your previous experiment so you can run new data. Assume the previous experiment is in a folder called 2016-05-18, which contains a data folder that in turn contains a folder named raw and processed. The goal is to copy the folder structure of 2016 folder into a folder called 2016-05-20 so that your final directory looks something like this. Great. I appreciate that they have that visualized for me. So which of the following set of commands would achieve this output? And what would the other commands do? So make directory. So we're making the parent directory, and then we're making a directory within it called data, and then we're making a directory within data called process, and then another called raw. That is one way to do it. Actually, that might just make... I'm going to have to see their solution, I think, because that might make just a lot of messy files. I kind of think that that would work though, to make directories in that way. So the second option, I dropped my pen. Make directory 2016-0520, and then change directories into 2016-0520, then make directory called data, change directories into data, and then make two directories, raw and then processed. So this I think should also work. It's just similarly kind of messy. So make directory -p. Did I write down -p? I did not. I'm picking up my pen so that I can write down -p. I don't know if this option will work. I'm interested to see though, because that would be way more efficient. So now we can make this option. I don't believe would work because we're not listing a path like we did up here. Because in this option we are showing the path, like we are showing make directory data processed and then data and raw, but this one is just still within this 2016-0520 directory, and then we're making a directory called data and then two more directories called raw and processed, so they would just be next to each other instead of nested. So let's see which of these actually work. So the first two work. Okay, that's kind of what I had assumed. The first set uses relative paths to create the top level directory before the subdirectories. The third set of commands will give an error because the default behavior of make directory won't create a subdirectory of a non-existing directory. The intermediate levels must be created first. That checks out. So we need to make the directories 2016-0520 and data before we can make raw and processed within those directories. The fourth set of commands achieve the objective. So the P option followed by a path of one or more directories will cause make directory to create any intermediate subdirectories as required. So I'm going to write that down so that I remember for next time. So -p option followed by a path causes make directory to create the necessary subdirectories. Very nifty. Okay, and then make directory 1605. This last option generates raw and process at the same level as the data directory, which is what we had thought. So that is not the correct answer. It will not give us our desired output. So this is very handy. This little key points, key takeaways. I'm just going to make sure that I have this written down. So CP has it copies a file and it takes two inputs. So it has an old as an input and then a new as an input, and then it outputs the file in a new place, or the file in a new name. Make directory path creates a new directory like we just saw above, and then move takes two inputs as well, so that's old and new, and it moves or renames a file or directory. Remove deletes a file, asterisk matches 0 more files, 0 or more characters in a file name, and then question mark matches any single character, so it has to be a single character. And then the use of the control key can be dictated in several different ways, and then the shell doesn't have a trash bin, so once something's deleted, it's like gone, fully gone. And then most files are named with a dot and then an extension at the end. It's not required, but it normally does indicate what type of data is in the file. And then depending on the type of work you do, you may need a more powerful text editor than Nano. So once we get to actually programming, we'll be using our Virtual Studio. But for now, we learned how to use Nano. All right. So I'm going to cross that one off our list. We just completed working with files. And now we're going to move on to pipes and filters. This will be the last command line lesson that we complete before going back to our lesson over here. This has been a very useful tutorial though on the command line. Really enjoying it so far. It's good. I'm just going to tab out right quick. I'm going to check on some things. Ooh, it's bright. All right. Oh, thanks for the follow, Captain Coda. Welcome to the gang. All right. How can I combine existing commands to do new things? So our objectives for this lesson are to redirect a command's output to a file. So construct command pipelines with two or more stages. Explain what usually happens if a program or pipeline isn't given any input to process, and explain the advantage of linking commands with pipes and filters. Now that we know a few basic commands, we can finally look at the shell's most powerful feature, the ease with which it lets us combine existing programs in new ways. We'll start with the directory shell lessons data, exercise data, proteins that contains 6 files describing some simple organic molecules. The PDB extension indicates these files are in protein databank format, a simple text format that specifies the type of position each atom in the molecule. That's cool that that has its own file type. I would never have guessed that that's what that means. But we are just going to change directory to desktop shell lesson data. We're going into exercise data, and then we're going into proteins. All right, so ls proteins. We're in the right directory, so I'm not sure why we don't have so there's no such file or directory listed. Makes me a little suspicious. What's going on? Okay. Did I accidentally delete it? I'm gonna look in our GUI. Okay, so there are definitely files in there. Alright, ls proteins. Cannot access, no such file or... I'm confusion. So ls-f gives us the correct. Maybe I need to go up. Okay, yeah, so, okay, cool. Yeah, it had just assumed that we were in the exercise data directory instead of in the proteins directory. So once we're inside of the proteins directory, it has a hard time listing what's actually inside of it with the protein. Like, you're calling on something inside of that directory, but there's nothing called proteins within that directory because that's the name of the parent or the current working directory. So we had to leave the directory in order to list it. We could list it from within using ls-f, but not the name of the directory since we were already inside. Sorry, I got really confused there for a second. I was like, what am I doing wrong? Alright. So we're going to change directories now to go into proteins. Now we're in there. And then we are going to run an example command called wc, and then we're going to use it on cubane.pdb. And I'm going to write wc down, so wc, because I'm assuming it's going to tell us what this does. So, loud, sorry. It's word count. Word count is what that means. So, it did list exactly what is listed here. So, it counts the number of lines, words, and characters in files from left to right in that order. So I'm going to write that down. It means word count. And then it will list lines, words, characters. That's a nice little command to run, because it's just running through the whole text file. It's running a count on how many characters, and then it's going back, running a count on how many words, running a count on how many lines. Really nice. So if we run the command wc *.pdb, the asterisk matches 0 more characters, so the shell turns into a list of all the PDB files in the current directory, and this will list every file within the directory. So we're going to wc *.pdb, and then it's going to list all of them, and we can then see our total word count, our total number of lines, but we can also see which ones are the longest, which have the most information in them, which looks like Octane has the highest number of characters and the highest number of words, actually being like more than a fourth of our total. A very useful command. So note that wc *pdb also shows the total number of all lines in the last line of the output. If we run wc-l instead of just wc, it shows only the number of lines per file, so that makes sense. I'm also assuming that if we run -w or -c, it'll give us the words, or -m or -w. So I'm going to do those right quick just to clarify which is which. So wc-l *pdb. So that's only the number of lines, and then wc-m *.pdb. That is just the characters, and then -w is going to give us the word count. So I'm gonna write that down again. I'm a chronic note taker, as you are no doubt seeing. So -l is lines, -m is characters, and then -w is words. Sweet. So why isn't it doing anything? What happens if a command is supposed to process a file but we don't give it a file name? For example, what if we type wc-l? So we don't type anything else after the command, it won't have anything to call upon. Since it doesn't have a file name, wc assumes that it is supposed to process input given at the command line, at the command prompt. So it just sits there and waits for us to give it some data interactively. From the outside, though, all we see is it sitting there. The command doesn't appear to do anything. So this is kind of cool. We can actually count the information that we're putting into the command line. It's kind of nice. So if you make this kind of mistake, you can escape out of this state by holding Control and typing the letter C. Once typing the letter C once and then letting go of the Control key. So I'm going to type that down, or not type, just write it down on my ever-growing legal pad. So WC can be used to count information in the command line. Use Control C to exit WC prompt. Simple enough. I'm into it. Okay, capturing output from commands. Which of these files contains fewer lines? It's an easy question to answer when there are only 6 files, but what if there are 6,000? Our first step towards a solution is to run the command length.txt. So this is going to run a sort on, JK, I got ahead of myself. The greater than symbol tells the shell to redirect the command's output to a file instead of printing it to the screen. So it's not running a sort, it's just outputting to a text file. This is why there is no screen output. Everything that WC would have printed has gone into the file length.txt instead. The shell will create a file if it doesn't exist. If the file does exist, it will be silently overwritten, which may lead to data loss, and thus use some caution. ls.txt confirms that the file does now exist. So we're going to do this in our command line. So we're going to write wc-l, so that's finding the number of lines, and then asterisk.pdg, and then we're going to tell it to go to a lengths.txt. So we're creating, lengths.txt. Now we're going to do that, and it will create that file name. So ls lengths.txt, and it should return that we have that file name. Great. Now we can send the contents to the screen by using cat. So cat gets its name from concatenate, or to join together. So it basically prints the contents of the file into our command line terminal. So I'm going to type cat lengths.txt. This would be really long if it were like a longer text file. We wouldn't do this with something that was like tens of thousands of lines long. Okay, so I'm going to write that down. Cat equals concatenate prints file text to terminal. Sweet. Good to know. All right, and Speaking can sometimes be hard for me. Okay. We will continue to use cat in this lesson for convenience and consistency, but it has its disadvantage is that it dumps the whole file onto your screen. More useful in practice is the command less, which you use with less and then your file name. This displays a screen full of file, then stops. You can go forward one screen full by pressing the space bar or back pressing B and then Q to quit. Very similar to how we interacted with the help and manual pages from Bash earlier in the previous episode. So I'm actually gonna write that down. That less can also be used to so less also prints to terminal. I think someone's vacuuming their car across the street. That's what the sound is. If you can hear the like whirring sound. I'm so sorry if you can't hear it. My windows are fairly thin. So less prints to terminal in more interactive, similar to manual. Interactive. i.e. manual. Okay. This is just a personal accomplishment that I'm very proud of, but we have officially made it all the way through our first page of the legal pad. We are flipping the page, flipping it over. We are now on the second side. Second side. Gonna have to use a different pen because that one is bleeding through. Okay. We're all set up with our new pen. Second side. Very exciting to me. Okay, the file shell lessons data, exercise data, numbers.txt contains the following lines. And we are going to sort at this point. I just started working through the algorithms textbook for later lessons. And so sort is very on my brain. I'm excited to do this. Let's go. First, we'll use an exercise to learn about the sort command. I'm interested to see if we have different sort commands for different types of sorts, but I doubt that we'll really get into this in this lesson. So if we run sort on our numbers.txt file, the output would be 10, 19, 22, 6. So it hasn't really done much of anything. But if we run sort-in on the same file, we get this instead in non-decreasing order. So explain why in has this effect. So we're basically giving sort an option and asking sort to put it into this order. So sort based on number. I'm assuming sort can also order outputs in alphabetical order or based on like extension type, which would have different options, but -in gives us the numerical order in non-decreasing order. I said it in too many words. Sorry. Alright, we will also use the -in option to specify that it's numerical instead of alphabetical, so I'm going to just write that down. So, sort. Sorts contents of a file. And then -in option dictating or indicating a numerical sort. Yeah. So, in practical use, we can use this to specify that it's numerical instead of alphanumerical. This does not change the file. Instead, it sends the sorted results to the screen. So we can sort in lengths.txt, and that gives us methane. That gives us the line count that we had done with our WC word count prompt, and that we had printed into our lengths.txt. We're now sorting that. So I'm going to go ahead and do that in here. So sort -n lengths.txt, and that is going to give us in our numerical order our size. So we can see that octane is our largest file, and methane is our smallest file in terms of lines. We can put this sorted list of lines in another temporary file called sorted_lengths.txt by putting another greater than sorted_lengths.txt after the command, just as we used greater than lengths.txt to put the output of WC into lengths.txt. Once we've done that, we can run another command called head to get the first few lines in sorted_lengths.txt. So let's go ahead and put sort-n lengths.txt. We're going to put that into a new file called sorted_lengths.txt. And then we are going to say head-n 1. Not sure why we need that, but that'll give us just the first line. That's saying how many got it. 1 sorted lengths.txt. So that gives us just the first line, which is methane, or just one line. It wouldn't be the first because that we would call with a 0, but it gives us just one line. So using -n1 with head tells it that we only want the first line of the file. -n20 would get the first 20, and so on. So it's up through. Since sorted lengths.txt contains the lengths of our files ordered from least to greatest, the output of head must be the file with the fewest lines. So redirecting to the same file. It's a very bad idea to try redirecting the output of a command that operates on a file to the same file. For example, if we tried to put our sorted lengths into our lengths text file. Doing something like this might give you incorrect results or even delete the contents of length.txt. Alright, moving on. So we've seen the use of greater than, but there's a similar operator that uses 2 of them, which works slightly differently. We'll learn about the difference between these two operators by printing some strings. We can use the command echo to print strings as shown here. So echo, the command echo prints text, and then that would print everything that follows echo. I'm just going to write down that echo is basically our console log. So echo prints to terminal. Everything that follows echo. I kind of like that name. It's very reminiscent of the space age. Echo. Okay, now test the commands below to reveal the difference between the two operators. So we are just going to do echo hello into test file testfile01.txt, and now we're going to echo hello test file 02.txt, and now I'm going to cat test file 01.txt. This will give us the same thing because I didn't do two of them. That's why it gave us that hint. So I'm going to just do this so that we can see it. Test file 02.txt. It's also going to give us hello. Now I'm going to also echo hello single one to test file 01.txt, and then also echo hello two of them to test file 02.txt. Now we're going to cat hello we're going to cat test file 01.txt, and we are going to cat test file 02.txt. So doing it once just prints that input once and only once into our destination file, whereas the double will print it to our destination file regardless of if it exists within that file already. So my guess is that the single greater than symbol is just ensuring that that input exists somewhere within the file, and not making sure that it is input again. I'm going to see how they describe it though, because I did not describe it very well. Okay, so in the first example, the string hello is written to test file, but it is overwritten each time we run the command. If we see from the second example that the operator writes hello to a file and then appends the string if it already exists. So we could run the second command with the two greater than symbols as many times as we want and have as many of them as we want. So it's adding to the file, but keeping the original. Sorry, I'm gesturing so much. I talk with my hands. But we're keeping the original integrity of the file intact. Whereas with the single greater than symbol, we are overwriting the file with new information. Great to know. There's an ice cream truck on my street. I can hear it. I can hear it out there. Okay. So appending data. We have already met the head command, which prints lines from the start of a file. Tail is similar, but it prints lines from the end instead. So consider consider the file animals.csv. After these commands, select the answer that corresponds to the file animal_subset.csv. So we're first going to print the first 3 lines of animal.csv into a new file called animal_subset.csv. Then afterwards, we are going to print the last 2 lines of animal.csv into that same file, animal_subset.csv. So So we will end up with the first 3 lines and the last 2 lines of animal CSV. So option 3 is correct. If we only ran the first command, the head command, we would have option 1. If we only ran the tail command, we would have option 2. And then for option 4 to be correct, we would have to pipe the output of head into tail 2 by doing head numerical 3 animal CSV absolute tail 2 and then send it to that. That makes sense. I think that's a little bit over my head, but that makes sense. Okay, in our example of finding the file with the fewest lines, we are using 2 intermediate files, length and sorted lengths, to store output. This is a confusing way to work because even once you understand what WC, sort, and head do, those intermediate files make it hard to follow what's going on. We can make it easier to understand by running sort and head together. So the vertical bar between the 2 commands is called a pipe. It tells the shell that we want to use the output of the command on the left as the input to the command on the right. So I'm going to write that down, and that's a great thing to know. So vertical line tells the shell to use output from left as input on right. So in the example listed above, this has removed the need for a sorted lengths.txt file, so we don't even need sorted lengths.txt. Excuse me. Oh, I got the yawns. That's really not good. I'm so sorry. Okay, combining multiple commands. Nothing prevents us from chaining pipes consecutively. We can, for example, send the output of WC directly to sort and then the resulting output to head. This removes the need for any intermediate files. We'll start by using the pipe to send the output of WC to sort. So we will WC-L. So we're calling for the word count of lines of all of the PDB files. And then I have to find where that character is on my keyboard. There it is. For me, it was just above the enter key on the right side. Not on my numlock pad on my 10 key, but on the main keyboard, the main ASCII keyboard. So pipe and then sort -in. Cool. So that gave us the same output as if we had printed our results to a file and then console logged them to the terminal, while also running a sort on those inputs. So we can send them through that. We can send that output through another pipe to head. So the pipeline, the full pipeline becomes as follows. So word count of lines of all .pdb files, and then we're going to send that to sort numerically, and then we're going to send that to head in 1. So we're only calling the first line of our sorted output. This should this gives us just the methane line. So this is exactly like a mathematical nesting function like log 3x, saying the log of 3 times x. In our case, the calculation is head of sort of line count of PDB. The redirection in pipes used in the last few commands are illustrated below. So we have word count list of all PDB files, outputs in the shell. And then previously we had put that into a text file called lengths. But instead, what we can do is get the word count, sort the word count, and then list in our shell just the first line of the output that we want. So piping commands together. In our current directory, we want to find the 3 file names which have the least number of lines. Which commands listed would work? So what we're going to start with is a word count. We're going to word count all of the files with the, so we'll word count lines all. This is great. And then we are not sending this to a file name called sort-1-in because that's first of all the wrong naming convention, and second of all we are trying just to get an output in our shell. So we actually will use this here, so that crosses out option number 1. Now here we're going to go ahead and run a sort because we want to make sure that we have the files listed in the correct order before we call the first 3, because if we call on the first 3, then we have no idea. Those could be listed in non-decreasing order and non-increasing order. They could be random order. So we're going to run a sort on those before we pull those first 3. So that rolls out option 3. Both 2 and 4 run a sort, and we're going to end up going with option 4 because we only need to list the end line. We don't need to list 1 through 3 because it will automatically pull 1 through 3. I'm going to pull my headphones off real quick. There's a noise and I want to make sure that it's outside, not inside. Yeah, it's the vacuuming again. Hopefully that's not a mainstay. And it's very exciting that they're getting their car clean. I always feel kind of creeped out by the ice cream trucks. It reminds me of It or something. Okay. So option 4 is the solution, which is what we had come to. The pipe character is used to connect the output from one command to the other. The greater than is used to redirect standard output to a file. Tried in the shell proteins directory. I think that we're good. Tools designed to work together. This idea of linking programs together is why Unix has been so successful. Instead of creating enormous programs that try to do many different things, Unix programmers focus on creating lots of simple tools that do one job well and that work well with each other. This programming model is called pipes and filters. We've already seen pipes. A filter is a program like WC or sort that transforms a stream of input into a stream of output. Almost all the standard Unix tools can work this way, unless told to do otherwise. They read from standard input, do something with what they've read, and write to standard output. The key is that any program that reads lines of text. Oh, excuse me. I'm going to have some water. Okay. The key is that any program that reads lines of text from standard input and write lines to text to standard output could be combined with every other program that behaves this way as well. You can and should write your programs this way so that you and other people can use those programs can put those programs into your pipes to multiply their power. So, a file called animal CSV in the shell, lessons data, exercise data, animal counts folder contains the following data. What text passes through each of the pipes and the final redirect in the pipeline below. Note the sort R sorts in reverse order. So instead of smallest to largest, it is non-decreasing, so it's largest to smallest. So cat animals CSV, we're gonna print this to the console log. We're gonna console log that to the terminal, sorry. Head dash in 5 gives us the first 5 lines, so that's going to be 1, 2, 3, 4, 5. So we're dropping Fox. We're dropping these last ones. And then tail 3, so I believe that's going to be just these 3. And then sort in reverse order. So that's going to be 19, 7, and then 2. So rabbit, raccoon, and deer. And then we're putting that into a final text document. So we should have a text final document that reads rabbit, raccoon, and then deer. So just these 3. So let's see if that is indeed correct. Oh, haha. And so I was just looking at these last numbers here, but I should have been looking at the dates because that will in fact give us 19, 2, and then 7. So I did an oops. But for the rest of it, we did get it correct. So the head command retracts the first 5 lines from animal CSV. Then the last 3 lines are extracted from the previous 5 using the tail command. With the reverse sort, those 3 lines are sorted in reverse order, and then finally the output is redirected into a final text file. The contents of this can be checked using the cat command. I'm just going to write down the -r, sort -r is reverse order, just so that I make sure that I have it. Great. Cool. Moving on. Alright, for the file animals.csv from the previous exercise, consider the following command. Cut -d -f to animals CSV. The cut command is used to remove or cut out certain sections of each line, and cut expects the lines to be separated into columns by a tab character. A character used in this way is called a delimiter. In the example above, we use -d option to specify the comma as our delimiter character. We have also used the -f option to specify that we want to extract the second field column. So -d is delimiter comma. So you can see option delimiter comma, and then option field is 2, and then our argument for what file is animals.csv. The output from this would be all of the second field. So since our fields are separated by the commas, that would be 1, 2, and then 3. I am kind of surprised that the command line is using 1 for the first, 2 for the second, 3 for the third, because I would assume that it would use 0 for the first, 1 for the second, and 2 for the third, just because of how other programming language call on indexes. I might post that in the Odin project Discord just to get some clarification on that, but just an interesting observation. So this command did give us the correct output. I'm going to write down that cut pulls just whatever we're referencing. Cuts out specific sections. -d defines delimiters between fields, and then -f calls which field we want. Great. So the unique command filters out adjacent matching lines in a file. How could you extend this pipeline using unique and another command to find out what animals the file contains without any duplicates in their names? Excuse me. So yes, so we would include this command and then have our pipeline. We would run a sort and then run also unique to ensure that we didn't have any duplicates from our sort. Okay, which pipe? The file animal CSV contains 8 lines of data formatted as follows. So we have date, type of animal, and then a number. So the unique command has a -c option, which gives a count of the number of times a line occurs in its input. Assuming your current directory is shell's animal count, what command would you use to produce a table that shows the total count of each type of animal in the file? So we would run a sort total number of. We are going to want to run a word count, I believe, because we'll want the number of lines. Running this will give us the list, and then it will so this would actually probably work. So this is going to sort the animals, and then it's going to take a count of how many times each animal appears. So I think this would work. I'm not sure what option T or option K-2 does, so I'm not going to say that one. Cut delineator, comma, line 2. So I think this, yes. I'm changing my answer. So this will give us a sort, and then it will say unique -c, and so some of these will not be identical. We want to call just the type of animal. So we are going to need to say cut delineator field 2, which would be the animal, and then call on the file name. So that gives us these last 3. And then just this would give us that whole list. We could run a sort. I don't necessarily think it's necessary. I'm going to say that 3 and 4 will both work. So 4 is the correct answer. Yeah, 5 wouldn't work because it's just going to give us a word count list of the lines, which is not what we're looking for. We're looking for the total count of each type of animal. I'm going to actually I'm going to go into animal counts, and then I'm going to run this. So cd or cut D is comma, F is 2, animal dot CSV pipe unique C. See what that lists. So and then we're gonna cut -d comma -f second animals dot CSV pipe sort pipe unique. So I'm just going to think about this for a second because I do want to understand it before I move on. So this is giving us unique. So it, okay, since we didn't sort, it's seeing each instance as an individual instance, I believe. So it's listing 1, 1, 1, 1. But since we sorted in this one, it grouped together bear, deer, fox, rabbit, raccoon. I think that's why. Alright, we're just going to finish up this lesson and then I'm going to call it for this stream because I'm getting hungry. It is lunchtime soon. So Nell's pipeline, checking files. Nell has run her samples through the assay machine and created 17 files in the North Pacific Gyre directory described earlier. As a quick check, she's starting from the shell lessons directory. She types the following. So I'm going to do this along with. I'm going to go up, cd. We're going to we need to go up again, so cd. Okay, now we are in shell lessons data, and we're going to change directory to North Pacific Gyre. Great, now we are in that directory, and then we are going to word count lines of all of the txt files. So this is going to give us a list, so we have 300 lines in each of our files. So now we're going to type word count lines of all .txt files, but we are going to pipe that output into a sort numerical, and then we are going to grab just the first 5 of those numerical outputs. So there we go. And we can see that we actually did have one that was 240 instead of 300, so that was actually very useful. So one of the lines is 60 shorter than the rest. When she goes back and checks it, she sees that she did that assay at 8 on a Monday morning. Someone was probably using the machine on the weekend and she forgot to reset it. Before rerunning that sample, she checks to see if any files have too much data. So we are going to wc-l all of our txt, and then we're going to run that through a sort numerical. Then we're going to run that and just grab the last 5 lines, and we can see that the last all have the same yeah. So the numbers look good, but what is Z doing on the third to last line? All of her samples should be marked A or B by convention. Her lab uses Z to indicate samples with missing information. So to find all others like it, she's going to run list all files z.txt. There we go. My bad, it needs to be uppercase. So ls all files capital Z.txt, and that's just the one, so that's good. Oh, there are 2 of them. So when she checks the log on her laptop, there's no depth recorded for either of those samples. Since it's too late to get the information any other way, she must exclude those 2 files from her analysis. She could delete them using remove, but there are actually some analyses she might do later where depth doesn't matter, so instead she'll have to be careful later on to select files using the wildcard expression, any all A txt and any all B txt. So removing unneeded files. Suppose you want to delete your file. I'm going to clear this because I like things to be clean. Suppose you want to delete your processed data files and only keep your raw data files. And processing script to save storage. The raw files end in .dat, where the processed files end in .txt. Which of the following would you remove? Which of the following would remove all processed data files and only the processed data files? So remove all .txt. I'm thinking it's number 2. So the question mark indicates only one character, so we would remove only files with single character names. 2 is the option that we chose. 3, it would expand to match everything in the current directory, so the command would remove all matched files and an additional file called blank.txt. And then option 4, it would expand *** to match all files with any extension, so it would delete all files. No good. So here is our little key points, key takeaways. So WC counts lines, words, characters in its inputs. Concatenate displays contents of its inputs. Sort sorts. Head pulls the first 10 lines of its input, or however many we depict. So head with an option N, and then however many we want, say 3, we would put a 3 in there. Tail displays the last 10 lines, or however many we call. So same thing as head, we would say tail -n, and then however many we want, we'll say 5 in this instance, we would put a 5 in there. So command greater than file name redirects the command's output into a file. It overwrites any existing content. And then file double greater than, command double greater than symbol and then file name, it appends or adds that output to a file. So first and then second, this is a pipeline, so the output of the first command is used as the input to the second. This way we can string along commands and have one set of inputs go through a long string of things and then output as whatever we had designed that pipeline to produce. And then the best way to use the shell is to use pipes and combine single-purpose programs as filters. Great! So now we have completed all of the listed command line basics lessons listed in the Odin Project's recommended list. So I'm going to cross that one off of our list. We did it! Whew, that took us a little bit of time. I'm kind of surprised that took as long as it did. I'm going to exit out of this one. So we've completed this. Okay, so with our newly discovered command line interface superpowers, create a folder and use files using make directory, touch, and cd commands introduced in the previous step. So as an example, a basic website may have a main index.html file, a CSS sheet called style CSS, and a folder for images. Think about how you could create these files with the commands and put it to practice. So what we'll do is we would make a directory called test. So I'm going to go ahead and go to my desktop. CD. Oops, desktop. Great, so now I'm going to make directory called test. And now if I move this over, there's a beautiful new directory called test. Fantastic. I did not want to do that. My bad. Oops. So now I'm going to change directory into our, now I'm within the test directory, and I'm going to touch index.html and then touch style.css. And finally, we're going to make directory called images. Now I'm going to ls.f, and we have our index, our style, and our images. And I'm just going to check. Look at that. Look at that. It's beautiful. We did it. That should make me excited, but I'm pretty excited. We did a thing. We did a thing, y'all. Okay. Okay, let's practice. Oops. I just did the thing that it said without reading. Okay, let's practice creating files and directories and deleting them. You'll need to enter the commands for the steps below in your terminal. If you can't recall how, scroll up for a reminder. Whew. So we've created a new directory in our home directory with the name test. Have done. Navigate to it. Have done. Create a new file called test.txt. So I'm going to say touch. I'm going to say touch test.txt. That's now created our test command. So open our newly created file in VS Code and make some changes. and then save the file. So I'm going to open VS Code. There was a shortcut for how to do that, but I cannot remember how. Okay, so I'm going to open. Desktop. Desktop. Test. Open. Yes, I trust. I am the author. I am the author of all files in my parent folder of desktop. So now I can open test.txt, and I'm going to what should we write? Great. And now we are going to save it. Save. Cool. And I'm going to exit out. So I'm exiting out. Great. Now we're going to navigate out of this directory. So I'm going to say cd ... We're back in desktop. And then we will delete the test directory. So all of the things that we just made, we're going to remove test. Oh, my bad. I wrote this down. I forgot. Yeah, I'm going to go back to here and then remember how to delete a directory. Nano draft, control, list, touch, remove my file. Change thesis. I think it mentioned remove above. Yeah. Sorry for the dead air. I'm just trying to find where it talks about removing. Yeah. List. Right. Great, we created that. Create that. Removing the file. Moving files and directories. Moving files and directories. Copy. -R goes back up a directory. Move. Okay, here we are. So remove -R is the recursive option. We'll remove the directory. So remove -R -I test. And then it's going to remove that. Remove regular empty file text style, yes. Remove directory images, yes. Remove file test.txt, yes. Remove directory test, yes. All right, we did it, and so that was the recursive option. So it went through everything that was within that directory, and then eventually asked us if we wanted to delete the directory itself. Very helpful, very useful. I should have remembered that, so I'm just going to write that down so I remember it for next time. So rm-r recursive allows removal of directories. Cool. All right. And that's all. We are done with practice. If you commit to doing most things from the command line from here on out, these commands will become a second nature to you. Moving and copying files is much more efficiently done through the command line, even if it feels like more of a hassle at this point. So using the command line like a pro, there's something important that you need to know about programmers. We are lazy, like really lazy. When forced to do something over and over again, the odds are they'll figure a way to automate it instead. The good news is that you can take advantage of the many shortcuts they've created along the way. It's time to use the command line like a pro, which is to say in a really lazy way. First, you might have already noticed that copying and pasting inside of the command line does not work like you expect. When you're inside the command line, you need to use Control-Shift-C or Mac Command-C to copy and Control-Shift-V, Command-V in Mac to paste. So I'm going to write that down. So Control-Shift-C is copy, and then Control-Shift-V is paste. Great. Second, you'll need to learn about tab completion. Seriously, this tip will save you so much time and frustration. Let's say that you're in command line and that you need to move into a folder that's far away, something like Documents, Odin Project, Foundation, JavaScript, Calculator. That's a long command to type out, and everything needs to be exactly right in order for it to work. We're way too lazy for that. Basically, by hitting tab, the command will automatically complete commands that you've started typing once there's only one option left. For example, it's pretty common to have documents and it downloads, So once you've typed D, press tab, and the command line will let you know it's not sure which one. But once you've typed a little more, it'll complete the name for you. So to get to Documents, Odin Projects, Foundation, JavaScript Calculator, we can do DOC tab, O tab, F tab, J tab, Cal tab. Because we might have calculations or we might have candles as a directory in addition to calculator. I'm not sure why we would have a candles tab, but we could have a candle directory in there, and that helps. Okay, this says to test it out, but I'm gonna just trust it, and I'm gonna write down tab notation, tab complete. I think we've done this once before, and I believe it was in that tutorial it had listed. Third, there's a really handy shortcut for opening everything within a project directory, dot. So once you've installed a text editor, you can use this shortcut to open up an entire project and all of its files in one go. This shortcut is also commonly used with Git. Later on it's covered in detail. With commands like git add dot to add all files inside of a directory and to get staging area. For example, if you have VS Code installed, you can cd into the project main directory and then type code dot with a period. It will launch VS Code and open up the file, the project folder in the sidebar. See you in the next section of this lesson for a more detailed example. A note on typing passwords. When using a command in the terminal that requires you to enter your password for authentication, such as sudo, the character should not be visible to you as you type them. While you might think the terminal isn't responding, don't worry. This is a security feature to protect confidential information like how password fields on websites use asterisks or dots. By not displaying characters, the terminal keeps your password secure. This really freaked me out the first time that I did it. I did not know that that's what was going on. I was like, why is my password not entering in right now? But it's just what it was saying. It was that it hides it from you. Very sneaky. It's good. Okay, opening files in VS Code from the command line. So Linux, you can open VS Code from the command line by typing code, and then you could open folders or files by adding the name of those locations after it. So I'm going to write that down. Code. And then directory name, dir name. Opens VS Code. Amazing. So for macOS, which we are not using, some setup is required. Once VS Code is installed, launch it any way you're comfortable with. Once it's running, open the command palette, Command-Shift-P. In the dialog that appears, type shell command. One of the choices that appears will be shell command installed code command in path. So select that option and then restart the terminal if you have it open. Then you should be able to type code same as you would in the Linux version. Here are additional resources. So this contains helpful articles. So Art of the Command Line is a pro maker, so we're going to open that. This online book is great. I love a good book. I'm not gonna, I guess we could look at chapter 1, but I'm kind of hesitant to spend that much time on that. Explain Shell is a great resource if you want to deconstruct a particularly strange shell command or learn how bash works through guess and check. Linux command sheet cheat sheet is a list of important commands that you can refer to regularly as you become familiar with Linux. You can print it out so you have a physical copy when you're not at your computer. Might be a good option for me. I'm going to add that. Command line flashcards, great. And then this video series by Linux Learn TV explaining the basics of the command line. Videos are brief enough for beginners, but at the same time, detailed enough to get you started and light your inner curiosity. So, these questions are just a knowledge check. I'm going to start these, but we'll see how, I think we can finish these before I'm through. Once we finish these, I'm gonna exit out. So, what is the command line? The command line is just our where we enter commands into our terminal. How do you open the command line on a computer? What do these do? They just take me to that section. Sorry for that awful scroll. Making people dizzy over here. Okay. How do you... Oop. Cool. How do you open the command line on a computer? That is Control-Alt-T. How do you navigate to a particular directory? So you would type cd and then the directory name, and that would be whatever path or whatever shortcut for wherever you wanted to go. So cd on its own will navigate you to just the topmost most parent directory. Cd ... will navigate you to the parent directory of the one you are currently in. How do you display the name of the directory that you are currently in? You type in pwd. How do you display the contents of the directory you are currently in? That would be lsf. My bad. Capital F is for friendly. I need to remember that. Capital F makes it nice to look at. Alright. Ew. So sorry for that sound. What was that? Little snort. Okay. How do you create a new directory? That would be... Oh. I'm gonna look that one up because, make directory. Oh my goodness. mkdir. How do you just create a new file? That would be touch, and then the file name. And then how do you destroy a directory or file? That would be rm, file name, or rm-r for a directory. And then how do you rename a directory or file? And that would be move, and then the file name or directory. But you have to be careful that you're not moving it to a place that already exists, because then you would potentially overwrite whatever pre-existing file name that you had or directory that you had, which would not be good. Okay, I'm going to exit out of the command line because I am done with it for today. I will just very briefly look into these. Ha ha ha. I like this. Aw. Those are very nice. Those are very nice. I like those a lot. Okay. So this is manual command, shows the manual for the specified command. This is a pipe touch command. It creates a file within the working directory. I'm not going to download those, but that's a very good resource to have. I really like this. I am going to download this to my desktop. Super cool. I like that one. Art of the command line. Might come back for this one later. But I'm going to mark this lesson as complete. We are done with the command line. And, well, we're not done with the command line. We're done learning the basics of the command line. I will say that we are officially beginners at the command line. Fantastic. Okay. It is getting a bit long at this point, so I'm going to call it. Thank you so much for joining and hanging out with me while I go through these lessons. I've had a great time today. I've apparently been redlining your ears this whole time, so I'm very sorry for that. And yeah, I'll see you in the next one. I'm actually gonna tab forward just so that we can see what the next lesson's about. So we're gonna set up Git in the next lesson. How exciting is that? Sweet. So we'll set up Git in the next lesson. And I'm going to shut this down. Great. Have a great one, y'all. I'll see you next time.